Today we're going to talk about how we find derivatives of compositions of functions. And the answer is we do use something called the chain rule. But before we find derivatives, let me review the idea of a composition. A composition basically means you are taking one function and plugging it into another. So one type of notation used for a composition is f of g of x. Another notation that you might have seen in the past would be f with a circle. It means the exact same thing, f composed with g. So let's do an example. If h of x is the square root of 2x plus 7, and we want to find f and g such that h is f composed with g, basically what they're asking us to do is to identify an inside function and an outside function. And so in this case, I would say that the inner function, the function that's inside another operation, is the 2x plus 7. And what function is that inside of? Well, it's inside a square root. So my g is 2x plus 7, and my f is root x. Now, to check my work, I could find f composed with g. In other words, I could take function g and plug that in for x on function f, and that does give me what I started with. If I replace the x with a 2x plus 7, I get the function that we started with. Now, the chain rule basically says if your function is a composition, so I think for my formula, rather than using the letters f and g because they come up in a lot of other types of problems, I'm going to say our function f is a composition of y with u. So we'll say y is the outside function, u is the inside function. Then the derivative of this function is the derivative of the outside function times the derivative of the inside function. So let's see how this works with an example. If f of x is 3x minus 2 to the fifth, I would say that my inside function, my u, is the thing inside the parentheses, 3x minus 2. Then my outside function, which I'm going to call y, can be written as u to the fifth. So the chain rule says if I want to find f prime of x, if I want to find the derivative of this function, I have to take u prime and multiply that by y prime. And so let's see, if u is 3x minus 2, u prime is 3. And if y is u to the fifth, then y prime is 5u to the fourth. So the chain rule says we take y prime, 5u to the fourth, times u prime, which is 3. Finally, we do have to write our final answer in terms of x. So we're going to replace that u in our answer with the 3x minus 2. In addition, I'm going to multiply the 5 and the 3 together. And so my final answer is going to be 15, 3x minus 2 to the fourth. Now, when I do these problems, I don't always show this much work, and you don't have to either. And so I'm going to try to do part B a little bit faster without showing all the work. And then I will erase it and show you the work as well, because I think for some of you, writing out the steps is going to be helpful. So in part B, f of x is square root of 3x squared minus 7x. Well, before I do anything else, I am going to change that square root into a 1/2 power. Now to find the derivative, I would say that my outside function is the 1/2 power. The inside is the 3x squared minus 7x. If we have something to the 1/2 power, the derivative would be 1/2 times that something to the negative 1/2. 1/2 minus 1 is negative 1/2. And the thing inside the parentheses never changes. So I'm just going to put in that 3x squared minus 7x. Okay, so something to the 1/2 is 1/2, something to the negative 1/2. And then the chain rule says we have to multiply by the derivative of that inside function. And so in this case, I have to multiply by 6x minus 7. So typically this is the work I show when I do chain rule problems. But as I said before, I'm going to erase this and write it out with the u's and y's in case that's helpful. So let's do the same problem again, this time writing out a few more steps. So The inside function, the u, is the 3x squared minus 7x. And then the outside function, the y, is square root of u. So my u prime is 6x minus 7. And square root of u is u to the 1/2. So my y prime is 1/2 u to the negative 1/2. Then the chain rule says the derivative of this function is y prime 1/2 u to the negative 1/2 times u prime. I would then change that u into an x. U is 3x squared minus 7x. So I get a 1/2 3x squared minus 7x to the negative 1/2 times 6x minus 7. Finally, if I were asked to write this using positive exponents, I would write this as 6x minus 7 over 2 3x squared minus 7x to the positive 1/2. Now the chain rule can be combined with our product and our quotient rules. And so in example C, x times root 5x minus 2, this is actually a product because of that x in front of the square root. So I have to use the product rule. My u would be the x, and my v is 5x minus 2 to the 1/2 power. I just changed that root to a 1/2 exponent. So then my u prime is 1. But now to find my v prime, I have to use the chain rule. I have something to the 1/2 power. The derivative is going to be 1/2 times that something to the negative 1/2 power. So 1/2 5x minus 2 to the negative 1/2 power. And then the chain rule says we multiply by the derivative of the inside function, which in this case would be 5. Derivative of 5x minus 2 is 5. So then using my product rule, I'm going to take u prime times v plus v prime times u. And so we could write this answer as 5x minus 2 to the 1/2 plus 5x over 2 5x minus 2 to the 1/2 power. And of course you can always change those 1/2 powers back to square roots if you prefer. The chain rule can also be combined with the quotient rule. So here's an example of a quotient. In this case, my u would be the x minus 2. My v is the denominator, which I'm going to write as 4x plus 1 to the 1/2. So my u prime is 1, and my v prime, something to the 1/2 power. I'm using the chain rule. So I get 1/2 something to the negative 1/2 power, or 1/2 4x plus 1 to the negative 1/2 power. Then the chain rule says we have to multiply by the derivative of that inside function, and the derivative of 4x plus 1 is 4. So my v prime, 1/2 times 4 is 2, 4x plus 1 to the negative 1/2, or 2 over 4x plus 1 to the 1/2. So using my quotient rule, I take u prime times v minus v prime times u all over v squared. Now I'm going to take the time to simplify this thing. And I'm going to simplify this because I have a complex fraction. I have fractions within fractions. And so what I'm going to do is I'm going to multiply everything by the LCD to clear the fractions. The LCD here is the 4x plus 1 to the 1/2 power. So I'm going to multiply everything on the top and everything on the bottom by that LCD. If I take the first term and I multiply that by the LCD, 4x plus 1 to the 1/2 times 4x plus 1 to the 1/2, we are multiplying two square roots together. We are squaring a square root, and that should just give us the 4x plus 1. Another way of thinking about it is you could add the exponents. 1/2 plus 1/2 is 1, so you get 4x plus 1. Now if we take that LCD times the second term, now the 4x plus 1 to the 1/2 cancels with that LCD, and all I'm left with is the minus 2x minus 2. In the denominator, I've got a 4x plus 1 to the 1/2 squared. Again, I'm squaring a square root. That gets rid of the radical and leaves me with just a 4x plus 1, and then times that extra 4x plus 1 to the 1/2. So I'm going to combine like terms in the numerator. I get rid of parentheses, distribute the -2, and if I combine like terms, that gives me 2x plus 5. And then in the denominator, I think I am going to add the exponents there. I have a 4x plus 1 to the 1 times 4x plus 1 to the 1/2. If I add the exponents, that gives me 4x plus 1 to the 3/2. And so there's my answer in a simplified form. I do want you to get rid of your negative exponents. So in other words, I do want you to be able to do this type of simplification in these problems. Finally, let's do one application problem. We are asked to find the equation of the line tangent to the following function. So the first thing I notice is when we're talking about tangent lines, the slope of a tangent line is always the derivative. So I have to find the derivative of this function. The function we're given is a cube root, and the cube root is the same thing as the 1/3 power. I'm going to use the chain rule to find my derivative. So this time I have something to the 1/3 power. The derivative is going to be 1/3 times that something to the -2/3. 1/3 minus 1 is -2/3. Or 1/3 x squared minus 1 to the -2/3. Then the chain rule says we have to multiply by the derivative of that inside function, and the derivative of x squared minus 1 is 2x. So we could write this derivative as 2x over 3 x squared minus 1 to the +2/3 power. Now I want to find the equation of the tangent line at x equals 3, so that means I need to figure out what is the derivative when x is 3. To do that, I can just plug 3 into my derivative. So I replace all the x's with 3's. I get a 6 on the top over 3 times 8 to the 2/3. It's fine to use a calculator to help you with this, but 8 to the 2/3 should be 4, and so that would be 6 over 12, or 1/2. Now to get the equation of a line, I always like to use that point slope formula. I know what the slope is. They're giving me an x value, so I know the x1. To find the y1, I am going to take my x value, and I'm going to plug that into my original function. So when x is 3, y should be cube root of 3 squared minus 1, cube root of 8, or 2. So my y1 is 2. Plugging this into my point slope formula, I get y minus 2 equals 1/2 times x minus 3. And that is my solution in point slope form. As always, don't hesitate to send me an email or drop by during office hours if you have any questions.